Hi everyone, so this is question 7 that we are going to solve now. So let's take a look at this question. Okay, so it says here that you are given a figure which is an acceleration against time graph, and it's for a body of mass 2.5 kg. Okay, so it's good that we jot down here. Mass is equals to 2.5 kg. And this mass is undergoing SHM, which is simple harmonic motion. So before we go into all those determine what and what, I think it's better that we fully understand what this acceleration time graph is telling us. In other words, we try to extract all the information from this acceleration time graph. Okay, when you're given a graph for SHM, when you're given a displacement time graph, a velocity time graph, or an acceleration time graph, basically you are given, it's similar to being given an equation of motion actually. So let me prove it to you. Getting a graph is similar to getting an equation of motion. So we learned from the previous video that the amplitude of this graph means by these peaks over here. Okay, the amplitude of the graph means by this value here. For acceleration time graph, it's representing a omega square and negative a omega square. Knowing this information, we can write it down. A omega square equals to 0.80. So it will be meter per second square. The next thing that we can, besides knowing things on the y-axis, for the x-axis, what we can see here is they've given to you that here is 0.6 second, but this is not a complete oscillation. This is 1.5 oscillation. A complete oscillation should go from here to here only. So we need to find the time at this particular moment. And this particular moment, that time will be our period. So I believe it's quite straightforward. If you see here, there's 1 portion, 2 portion, and 3 portion. Only you have 0.6. And for a period, you need 2 portion is enough. So it's straightforward for us to say that T will be equals to 0.6 divided by, that's 3 portion, but you want 2 portion only, which is equivalent to 0.4 second. Okay, knowing all this, we can further process this a omega square here. Usually when we obtain something, we will try to obtain either an a, and we'll try to get either this, or this. Okay, so the a omega square that we have here is a bit not the simplest way of representing things. We can probably represent in terms of amplitude a. Okay, so what can we do here is we can put in the value that we get. Okay, for omega we know is 2 pi over big T. So let's just put in 2 pi over 0.4 square equals to 0.80. We substitute the omega with knowing, because we know T. If you know T, we are able to get omega using 2 pi over T. So if we move everything around, we'll be able to obtain A, which is equals to 3.24 times 10 to the power of -3 meter. Okay, so this is the amplitude for this particular simple harmonic motion. So we get A, we get T, and we know omega, all those things. I think we understand this whole graph quite clearly, that we are able to solve the question now. So for question A, determine the period. Oops, seems like we've already done it. Here is just 0.4 second. B, the amplitude, oops, again we have done it as well, 3.24 times 10 to a power of negative 3 meter. See, by understanding our graph in detail, being able to extract all the important information from the graph, for this case our amplitude and period, by extracting all the important stuff, all the questions will become quite straightforward afterwards. Okay, the maximum speed of the body, well, it's just Vmax, and I believe you are very familiar with the formula now, which is plus minus amplitude times angular velocity, a omega. And if you substitute everything inside, 3.24 times 10 to a power of negative 3 times omega, which is 2 pi over 0.4. You should be able to get the answer 0.051 meter per second. So that's Vmax. If you are wondering how do I get the omega here, this omega is the same as the omega here. And to get this omega, it basically comes from omega equals to 2 pi over t. Okay, so until now I believe all the questions are relatively straightforward. So the last question we have here is to determine the total energy. Total energy. Okay, I believe you know that total energy is either half Ka square. If you look around for this question, I don't think you are given any information for K. For the force constant K, you are not given any information. So let's try another equation instead. M omega square A square. Now things seems possible because you are given the mass of the object undergoing SHM. So what you can do here is to continue with substitution. Half 2.50 omega will be 2 pi over 0.4. It's 2 pi over big T again. And amplitude will be 3.24 times 10 to a power of negative 3 square. And if you calculate everything, the answer should be 3.24 times 10 to a power of negative 3 joule. Okay, looks quite interesting. The amplitude and the energy are having the same value. Okay, so this is total energy. So what I want to emphasize here, we have already finished the question, but what I want to emphasize here is extract the information. If you are able to extract the information, then everything should be quite straightforward afterwards. What info we need to extract? It's either the amplitude should be in big A, sorry. It's the amplitude and one of either omega, T, or F, one of them. If you extract these two things, the rest of the question should be quite straightforward. Okay, so that's all for question 7. Thank you very much.